Okay, hi Dr. Aikal. Today I'm going to present our open-ended experiment, which is producing citrus oil from lemon peel using steam distillation method. It is solid liquid extraction experiment. So our group, which is group 2E, stands from me, Yuvaras Analai Kunalan, 196320, Cairo bin Abdullah, Ong Hui Ling, and Tarania Balamurugan. So I will start my presentation with the introduction of our experiment. So the introduction: in this project, steam distillation is used to extract citrus oil from lemon peels. Citrus oil is primarily used in perfumery due to its pleasant odor, but it is also used in food products such as sweet beverages and cakes. Besides, citrus oil is also used in pharmaceutical industry to flavor distasteful medicine so that they are easy to consume. The oil also find application in extraction process as an eco-friendly solvent as major constituent of the oil in Lebanon. The objective of the experiment is to extract the maximum amount of citrus oil from lemon grove by steam distillation, which is steam distillation is the method that we choose to extract the oil. Okay, so I will explain the methodology of the experiment. So there is consists of two parts, which is part one, steam distillation, solid liquid extraction, and part two is liquid extraction actually. So for the first part, to extract the oil from lemon, we need to grate the lemon peel by using a cheese grater, and then put it into a flat bottom flask by using a funnel, and then add until it reaches the half of the flask. Set the distillation apparatus accordingly with the thermometer and so on, and then add stir bar to the flask. The function of the stir bar is to prevent overheating when there is no stir bar. So when there is a continuously stirring bar, it is the heating process will be consistent. Next, heat up the bottom flask by using the heater, and then after 1 hour and half, check the solution contains oil or not by taking the drops of the product that you achieve. If yes, continue the distillation process for about 1 more hour, and then turn off the heater, recover the remaining solution in the refrigerator. Collect the extracted oil in the receiving flask. If no, when you check there is no oil product, so you need to stop the distillation and proceed with liquid extraction by using the extracted solution just now. Okay, this is the second part, which is liquid extraction by using hexane as a solvent. So first, place a separative funnel in the retort stand. Pour the extraction solution from the previous step to a separating funnel. Wash the receiving flask with water for a few times and pour it into the separating funnel. Add 10 ml of hexane to the funnel and stopper it placed. So next, shake the funnel for a few times to release the pressure, and then let it stand for a few seconds. Open the stopcock and drain the aqueous phase into the Allen Merrill flask. Close the stopcock. Once the desired product is collected, recover it in a separated beaker. Repeat this step by using 5 ml of hexane. So actually, why we need this? Because when the extracted oil, the first part, contains oil and water. So we need to separate the oil and water by using the organic solvent, which is hexane, as we choose the solvent during our experiment. So we can separate the oil and water to get pure citrus lemon oil. And then next, this is the last part. We're going to take another part to remove hexane from the extraction that we extract just now. So first, heat up the remaining solution from the previous step at 62.5 until it boils, where the boiling point of the hexane is 62.5 degrees Celsius. But we can set it even more so that it will be even pure. There is 0% of hexane in the oil that we going to extract. So when the solution left only 10 ml, then pour it into a separated beaker. Continue heating the remaining 10 ml extracted solution at low heat. Check the temperature solution is reached 80 degrees Celsius or not by using thermometer. If no, repeat back the experiment. When the solution left 10, then pour it into a separated beaker. If yes, stop heating, take the weight of the final product and calculate the yield. So that is the final product that we achieve, which is citrus lemon oil. So that's all from me for my part. Thank you very much, Dr. Haikal. Next will be continued by my other group mates. Thank you very much.
I'm going to explain about our results that we get from our steam distillation of lemon peels for citrus oil extraction experiment. Our manipulated variables is effect of temperature and effect of time. So table 1 is about effect of temperature. At 88 degrees Celsius, our volume of citrus oil extracted is 0.90 milliliter. At 90 degrees Celsius is 2.65 milliliter. At 92 degrees Celsius is 4.50 milliliter. At 94 degrees Celsius is 6.40 milliliter. At 96 degrees Celsius is 8.50 milliliter. At 98 degrees Celsius is 8.50 milliliter. So based on this table, we know that 98 is our maximum temperature and we managed to collect 8.50 volume of citrus oil extracted from our lemon peels. And now, table number 2 is about effect of time on steam distillation of lemon peels for citrus oil extraction. Our reading is recorded at time 15 minutes and the volume of citrus oil extracted is 0.90 milliliter. At 30 minutes is 2.25 milliliter. At 45 minutes is 5.10 milliliter. At 60 minutes 7.00 milliliter. At 75 minutes is 8.50 volume of citrus oil extracted. So from this result we know that at 75 minutes, that is 1 hour 50 minutes, we managed to collect 8.50 milliliter of volume citrus oil extracted from the lemon peels. This is the maximum volume that can be extracted from the lemon peels. Okay. Now I'm going to explain our discussion part. Why we choose lemon peels as our raw materials. This is because the method of producing oil by extracting lemon is quite easy and it took some time for the product formation. Besides, lemon oil has a lot of benefits to human beings and environment. First one is used as a stress reliever. A research shows that inhaling this aromatic oil will help us to decrease the anxiety. Second one is contributes in cleansing and purifying the hair and surface in a house. It helps to keep a house smelling fresh, bright and more comfortable. Why we choose a steam distillation as our method to extract the oil from the lemon peel? Because the equipment used is inexpensive and easily found. It works well with unstickable substance and thus it is a cost-effective method to invest. Okay, our manipulating variables is temperature and time. The main target of this experiment is to extract the maximum amount of citrus oil from lemon grouped by steam distillation. Okay, at the first reading from this experiment is run at 88 degrees Celsius for 60 minute time frame. The distilled product is gathered in a conical flask, that is the initial oil, our distilled product. And we found that at 2 layers, which one high density layer and less density layer. Then it was then isolated by utilizing a separating funnel. The less density upper layer is a citrus oil. The experiment was run to observe the amount of oil extracted by changing the temperature with interval of 2 degrees Celsius where the time is kept constant. And the same goes to the when we do experiment about the time, the effect of time in the volume of oil extracted from the oil peel. Okay, in the second stage, the experiment was run to observe amount of oil extracted by changing the time with the interval of 50 minutes and keeping the time and the amount of lemon peel constant. Okay, hypothesis of this experiment is as the time increases, the production of lemon oil extracted will increases. Based on our researchers, that is Chelgini and Kumar, they say that as the temperature increases, the amount of citrus oil extracted also increases.
A very good day to my beloved Dr. Haika. My name is Ong Hui Ling and my matrix number is 198876. I will explain on the discussions of the result. So from the result we have plot the graph. So this is shown in figure 1. So this is a graph of volume of citrus oil against the temperature of steam distillation from lemon peel. So from figure 1, it can be observed that the volume of citrus oil obtained from lemon peel is almost increasing linearly with the temperature until it reaches 96 degrees Celsius. The volume of citrus oil obtained after the temperature reaches 96 degrees Celsius is constant. Any further increase of steam temperature above 96 degrees Celsius yields no effects on the volume of citrus oil obtained. This is because at a high temperature, the charring of lemon peel takes place at the bottom of flask. So next slide. So okay, this I have explained in the previous. So this one I have explained in the previous slide. So at 88 degrees Celsius, the oil extracted was only 0.9 milliliter. Okay, we can see in the graph. So at 88 degrees Celsius, the oil extracted was only 0.9 ml, while at 98 degrees Celsius, the oil extracted was 8.5 ml. And expansions in the temperature improve the solvency of the oil. As high temperature, it can disturb the cohesive and adhesive attraction between the oil atom and the oil lattice particles individually in this manner. So it expanding the dissemination pace of the oil. The capacity of higher temperature to quicken the extractions of essential oil is by a fast increment in temperature, causing a vigorous development in volume inside the plant cell. The cell divider can withstand such high inner weight coming out with crack of the cell and organ of plant material all the more quickly. So this is actually we get from the journal Camel 2001 and Quaffen and Kristen 2002 and Rachel et al. 1996. So we actually these informations we get from 3 journals. So the higher of the extraction temperature, it will diminish the quality of these dissolvable intermolecular powers, and in this way its consistency permitting better penetration into the matrix particle and diminish the surface pressure permitting the dissolvable to all the more likely cause the feedstock and subsequently increment paces the oil extraction. So next. So the next graph is a graph of volume of citrus oil extracted against the time of heating. So this graph is also plotted against this. In this graph, the manipulated variable is the time of heating, while the responding variable is the volume of citrus oil extracted. So actually, in this experiment, we manipulate 2 variables, which is the time of heating and also the temperature. So this is based on the result that we get from table 2. Okay. And then we plot this graph. So according from figure 2, it is observed that with the increase of distillation time, the volume of citrus oil increases until it reaches the maximums at 75-minute duration. So any further increase in time after 75 minutes has no effect on the oil yield. Okay, at 15 minutes, the amount of oil extracted was 0.9 ml, while at 75 ml, the amount was 8.5 ml. As the time of heating process increases, it will weaken the plant cell as well. So slowly the oil from the cell will dissolve in the solvent. At the maximum time, the plant cell will be fully cracked and the maximum oil will be obtained. So this is the main reason why as the time increases, we can obtain higher amount of oil. So next, so this one actually I have explained in the previous slide, which I have explained just now. So when the time increase, we can obtain a higher amount of oil. So this is because as the time of heating increases, it will weaken the plant cell as well, and then slowly the oil from the cell will dissolve in the solvent, and at the maximum time, the plant cell will be fully cracked and the maximum oil will be obtained. That's all from me. Thank you.
So for the conclusion, the volume of citrus oil is increasing linearly, the oil from the lemon pits, as the temperature increases until it reaches 96 degrees Celsius. With the increase of steam distillation time, the volume of oil extracted increases until it reaches the maximum at 75 minutes duration. The main objective of this experiment is to extract essential oil of plant solid through solid-liquid extraction process. Therefore, the main objective has been achieved as we successfully conducted the experiment and obtained the citrus oil. The volume of citrus oil we obtained is 8.5 milliliter. Recommendation: the lemon peels is finely cut, crushed or ground in order to get biggest total surface area to volume ratio. This action could increase the rate of distillation process. Then dry the lemon peel before carrying out the experiment. Stir the mixture by adding stir bar in the round bottom flask while carrying out the experiment. So this is the pictures of our group conducting the experiment. So the first picture shows that picture of grating the lemon peel into smaller pieces. Then the second picture is all the lemon pieces which has been grated, which has been peeled, is on the beaker, is in the beaker. Then picture 3 and 4 shows that the steam distillation apparatus setup. So this is how we set up the distillation for the distillation process. So the fifth picture shows that the picture of a round bottom flask, which there's a lemon peels inside there, and there's a picture after the steam distillation. It looks very dry because the steam distillation process has been taken over. Then the picture number 6 shows that the liquid extraction using separating funnel. So this is the process where we extract liquid extraction. Yeah. So the photo 7 shows that heating to separate hexane and essential oil. So for this process, we heat up the mixture which contains hexane and essential oil. We heat up until 70 degrees Celsius so that all the hexane has been evaporated. Then we left with the pure essential oil. Then last picture shows that essential oil. So this is the oil that we obtained, and it is 8.5 milliliter. And this is our group 2E. This is the picture during we conduct our experiment. Yeah, that's all. Thank you.